So today we are going to be talking about a concept called completing the square. And before I talk about your notes, let's review a little bit. If I asked you to factor this quadratic, we would go through and we would say, all right, x times x is x squared. And then we'd think about how to multiply to get a plus 9, and most of you would settle on plus 3 and plus 3. Because the outside and the inside do add up to 6. Well, there's another way to write this quantity. There's a shorthand notation. It's x plus 3 quantity squared. That just means I have two x plus 3's multiplied by each other. This is called a perfect square trinomial. And if you can recognize that you have a perfect square trinomial, they're actually really easy to factor and FOIL out. So if you look at the middle term, 6x, could you half that for me? What's half of 6x? Or half of 6? 3. And if you take that half number and you square it, that's the last number. So if I use that pattern, and I try to quickly think about this problem. Does this fit that pattern? What's half of 10? 5. And if I square that, it gives me a 25. Very good. So we're going to be using that sort of skill today where we're going to have a partial perfect square trinomial and then we're going to fill it in so it becomes a perfect square trinomial. And then today we're going to talk about rewriting quadratics into different forms, and then tomorrow we're going to use this skill to actually solve a quadratic equation. So if we are trying to complete a perfect square trinomial, we're going to start with the expression 1x squared plus bx plus blank. You don't need to fill in anything in the blank. We literally are going to draw blanks today. Then you're going to take half of your b term, so they're referring to this number right here, take half of it and then square it. Now whatever that number comes out to is what we put in the blank. Once you fill that in, you end up with a quadratic that's really easy to factor. He always factors into this pattern, x plus half of b times another x plus half of b, or we write it as x plus half of b squared. Let's see some examples with numbers. It'll make a lot more sense. So, one more note though. If you have an a in front that is not a 1, that means we got some trouble. This technique only works if your a value, this guy right here, is a 1. So if a is not equal to 1, then I either have to factor the a value if it's an expression, or we can divide if it's an equation. Turns out today in Algebra 2, I'm not going to make you do either of those things for today's lesson. I'm going to keep them real basic today. But if you ever are like an ACT test or a PARCC exam, and they give you an a value that's not 1, you either have to factor it out or divide by it. And we'll see some examples later on for like a challenge problem. All right, let's see an example. I want you to take this partial trinomial and I want you to complete it so it's a perfect square. So it says, write the expression in this format. So for our problem, it's going to be x squared plus 10x, and then literally you're going to write plus blank. And now I want you to calculate half of your b term. So your b term is 10. So if I take 10 and then I half it, that gives me a 5. Now it says, whatever that number is you just found, so in our case 5, I'd like you to square it. So what is 5 squared? 25. So I'm going to go back up to this trinomial. And instead of x squared plus 10x plus blank, I'm going to write it as x squared plus 10x plus, I put the 25 in the blank. Now the reason I chose to put a 25 there is because now when they ask me to factor it, this is going to be the world's easiest factoring problem. You could factor it old school, like reverse FOIL, or, let's do it old school first. It'd be x and x, and then what multiplies to a 25 and adds up to a 10? Plus 5 plus 5. Give me a shorthand way to write x plus 5 times x plus 5. X plus 5 squared, quantity squared, good. So now we're going to use that that skill to solve quadratic equations, but I think we're actually going to save that for tomorrow. So for today, let's just keep completing the square. All they want you to do is what value completes the square for the expression. I think we're going to take a few of these to the next level and actually go ahead and factor it, but the most important part is that you guys can figure out what goes inside the blank. So the pattern is you take half of your b term and then you square it. That's what goes inside your blank. So if I took half of my b term, which is half of 2, and then I square that number. Well, guys, what's 1 squared? That's a 1. So my new expression is x squared plus 2x plus 1. Can someone take this a step further and please factor x squared plus 2x plus 1 for me? Written like this, though. Be x plus 1. Very good. Quantity squared. So the actual answer to the question was you guys coming up with this plus blank, plus 1. But don't be surprised if in the near future I ask you to take it further and factor it. All right, let's talk about... it's when you get to your bookwork tomorrow, they are going to... Bookwork's not tonight. We have a worksheet tonight. Bookwork tomorrow, they're going to have a section that looks just like this where you find the value of that completes the square and then you stop. All right, so what goes in the blank? Let's see. I take half of b, which is this time a negative 24, and then I half it. And then I'm going to square that number. So negative 24 cut in half is negative 12. What happens when you square a negative 12? You get a 144. What do you think is true about this last value? It's always going to be positive. Can you tell me why? When you square a negative, it turns to a positive. Yep, absolutely. Can someone take this a step further? Can you take this trinomial and write it in its factored form? Go ahead. Awesome. You even caught the negative part. So x minus 12 quantity squared. Very good. So if only all factoring questions were that simple. We know they are. All right, let's talk about what goes in the next blank. Take half of your b term and then square it. So what's 6 squared? 36. Very good. Let's just go ahead and fill out the missing terms on the rest of these. So next question, half of your b term, negative 20 cut in half, and then square that number. 100. Very good. All right, this one's weird. If I took half of my b term this time, that'd be a 5 over 2. That is a decimal, but it's actually better if you keep it as a fraction. What happens when I take 5 over 2 and then I square that fraction? 25 over 4. Very good. And that's what goes in the blank. Now, if you were already working ahead and you wrote it as a decimal, that's okay. But we prefer the fractions. So knowing that, let's look at number 6. I'm going to take half of my b term. This time it's negative 9 cut in half. That's a fraction. That's not going to reduce. So let's go ahead and just square it as a fraction. Yes, sir? 81 over 4. Perfect. So all I'm asking you to do at this moment is can you come up with that last number that makes this a perfect trinomial? This is what we call a perfect trinomial, something that factors really beautifully like those all are going to. Well, we're going to use that skill now. And we're going to take the completed square quadratic. We're going to do a little bit of math magic, and then we're going to write a standard form quadratic into vertex form. So if I recall from, let's see, 4.1 and 4.2, you guys had a couple of equations of quadratics. This was one of them, and this was the other. And when I had you graph these quadratics, we decided that if it was given to me in, who remembers the name of this form? Vertex form. If it was given in vertex form, we did a little internal happy dance because that was easier. Why was it easier? Because you can see the vertex. Bam, there it is. What's the other one called? Standard form. We were a little less excited about standard form. Why? I'd have to calculate the vertex, and none of you like to calculate anything. Had a formula, you had to do negative b over 2a, you had to go to your table. So we were much happier if it was given to us in vertex form. And I mentioned to you in that lesson that we could easily at that moment go from vertex form to standard form, not that we wanted to. But I also mentioned in the future we're going to be able to go from standard form back to vertex form. Guess what, guys? It's the future. Here we are. Ready for this? Okay, we're going to take a quadratic equation, or a function I should say, y equals x squared minus 6x plus 14. That is in standard form. And I'm going to use some math magic, and I'm going to write it in vertex form. Now, do you guys understand that, first of all, there are two sides to this function, this equation. There's the y equals side and then the body of the function over here. Whatever I do to the equation, I need to keep it balanced. And I know normally, just for argument's sake, if I added 10 to the left side, I would also add 10 to the right side, because, you know, that's how math works. But what if I told you I was not allowed to touch the left-hand side at all today? What's another way to keep an equation balanced? Instead of adding 10 to both sides, yes, what if I add 10 and subtract 10 on the same side? Would that keep it balanced? And in your heads you're like, well, that'd be dumb, because they'd cancel each other. Let's wait and see what happens. They're actually not going to cancel each other. All right, y equals, put a little y equals in front of this. We're just going to focus on the body of x squared minus 6x, and then could you put a plus blank like we've been doing in the previous problems? So now what I'd like you to do is calculate that half of the b term. So for our problem, negative 6 cut in half is negative 3. Now we know that we're going to square that number. So what's going to be negative 3 squared? It's going to come out to a 9 in a minute. But for now, just go ahead and put a negative 3 in this blank. And then once we fix it and square it, that becomes a plus 9. So what you guys just did was you completed the square. But remember, I have an equation that I needed to keep balanced. So if I add 9 in this blank, and I need to keep this equation balanced, do you remember how there was a weird plus 14 I didn't talk about yet? I kind of shoved him off to the side. What if we also subtracted 9? Have I affected the balance of the equation at all? No, I could do whatever I want. I could add 1,000,000 and subtract 1,000,000 a minute later, as long as I did it on the same side. So you guys were thinking this was really dumb, because the plus 9 and minus 9 are canceled. I'm going to cross them off. You control how you group the equation together. So what if we focused on these three numbers as being a group, and these two numbers as being a group? X squared minus 6x plus 9. That's a perfect trinomial, which means you're going to be able to factor it into a perfect binomial. How does it factor? X minus 3 quantity squared. And then y'all can give me a better name for 14 minus 9. That's a 5. Are you in vertex form? Yeah. Look at that. Oh, that was nice. So what's your vertex? 3, 5. That's almost like magic. This is what I appreciate about algebra. Like, you can manipulate it to work for your situation. This is one of my favorite things about algebra, actually. I don't know. It feels like it's not useful, but it's actually extremely useful, because if you have a problem that you can't do with the skills you have, you can manipulate it so it looks a way where you can do it. All right, let's try a few examples here, guys. This is kind of weird. So what's going to happen is we're going to keep y equals on the left-hand side, and I am not going to touch anything on the left-hand side. It's always going to say y equals. But on the right-hand side, I'm going to do a whole bunch of magic. Let's start with the x squared plus bx part. So I'm going to write x squared plus 4x, and then I want you to put a plus blank. Now, a little after that, you still have the plus 3, and then what did we do to keep it balanced? I have to subtract whatever I put in that blank. So in the blank, I take half of the b term, so half of the b term, and then I square it. 4. Add 4, subtract 4. Yes, sir? Well, I could, but I want to do it in a way so that it factors nicely. So I guess in theory I could, but I don't want to. Alright guys, the reason we did that, even though it looks like they're going to cancel each other, we're now going to strategically group this together. This trinomial right here, x squared plus 4x plus 4, he should factor into a perfect binomial like this. Who can factor that for me? X plus 2 quantity squared, very good. And then this guy, 3 minus 4, better known as subtract 1. So can you tell me where your vertex is? -2, -1. Very good. It's funny because we haven't learned how to solve through completing the square yet. That's tomorrow's lesson. But once we learn that, you guys are going to think it's kind of neat. And every year we teach the quadratics unit, you guys end up with like 4 different methods of solving quadratics. And if given the choice, do you know what method pretty much every child uses? This one. Which, as a math teacher, I'm like, well, that's weird. I don't know. Everyone likes this one. We will find out later that this method is not appropriate for certain problems, and we'll see what that looks like. All right, guys, 14. Do not touch the left-hand side. It's just going to keep saying y equals, y equals. But on the right-hand side, we're going to kind of space it out. So x squared minus 6x. I'm going to leave a blank so I can complete the square. You guys still have this plus 13 off to the side, but to keep it balanced, whatever I added to that side, I now also have to subtract if I stay on the same side. Anyone want to figure out what goes in the blank? Yes, sir? Oh. You don't want this to be a negative sign because I want it to factor. So you want to follow the pattern the same way. Anyone thinks they know what goes in the blank? 9. Very good. Half of -6 is -3. If I square that, I get a 9. So to keep it balanced, if I add and subtract 9, I haven't affected the equation. But this does factor nicely. Can someone factor that trinomial for me? -3, quantity squared. Very good. And then 13 minus 9, better known as plus 4. So tell me where your vertex is located. 3, 4. Awesome. So remember those extra credit puzzles that you guys could have grabbed on Friday with all the weird coloring book pages? There's a couple worksheets in there where it says, like, find the vertex. You could, in theory, graph every single one of those on your calculator and find the vertex that way. Or you could do this. This way is kind of smooth, so it's up to you. All right, a couple more examples, and then we'll start our practice. All right, space it out a little bit. X squared plus 8x. Leave a blank so we can complete the square. This minus 10 is still off to the side. And then whatever I added in that blank, I also have to subtract it. So do a little math, follow the pattern, and tell me what goes in the blank. 16, very nice. So I'm going to add and subtract 16 to this side. So now you should be able to factor x squared plus 8x plus 16. Yes, sir? Who's got it? Plus 4? Yep, x plus 4, quantity squared. And then -10 minus 16, better known as subtract 26. Very good. That's weird. All right, so the vertex is located at -4, comma, -26. Oh, you were just jumping along, huh? All right, let's take a look at 16. How about I freeze the screen? My viewers in YouTube land will know what's going on, but y'all won't. Try it. Let's see how you do. Was that an old lady thing to say? Is that what you're trying to imply? YouTube people, that's the end.